The Corncob, 28 cylinders, 4 rows of 7, stacked one behind the other, 4,300 horsepower out of one propeller shaft. This is the Pratt & Whitney R4360 Wasp Major, the largest displacement piston aero engine America ever mass-produced. 71 liters in one lump, hanging off a wing. Look at how the rows sit. Each ring of 7 cylinders is twisted slightly against the ring in front, so the whole engine forms a shallow helix. That is not styling. That is how cooling air reaches the rear rows at all. Air cooling one ring is easy. Everything's out in the wind. Air cooling 4, where 3 of them hide behind the first, is the entire engineering problem, and that twist is Pratt & Whitney threading air past each row to the one behind it. It mostly worked. Mostly. Rear cylinder temperatures stayed a problem, and that complexity is what made it brutal. The B-36 carried 6 of these. That's 168 cylinders per aircraft, everyone air-cooled, everyone needing a man with a spanner. It is the high watermark of the piston aero engine. It arrived just in time to be obsolete. The fake first jet. Italy told the world it had flown the first jet aircraft. It had been beaten by a year, and this wasn't the kind of jet anyone meant. The Caproni Campini No. 1, August 1940, and the layout is strange in section. There is a 900 horsepower Isata Fraschini piston engine buried in the fuselage, a completely ordinary one. It does not turn a propeller. It turns a compressor. That compressor rams air down a duct running the length of the aircraft. A burner at the back adds heat, and that is your thrust. It's a motor jet. Jet propulsion, with a piston engine sitting where the turbine should be. Here's the number that ends the argument. 1,600 pounds of thrust for a top speed of 233 miles an hour. Slower than the propeller fighters it was built to replace. And that's the dead end. A turbojet puts a turbine in the exhaust and lets the hot gas it has already made drive its own compressor. Campini was hauling 900 horsepower of piston engine around to do a job the exhaust could do for itself. Germany had flown that a year earlier, in secret, not the first, and not the jet they meant. The H-24 cylinders, 3,500 horsepower, and not one poppet valve in the cylinder heads. The Napier Sabre is 2 flat 12 engines stacked on top of each other, running 2 crankshafts geared together. That's where the H comes from. Instead of valves opening and shutting in a head, the Sabre uses sleeve valves. The cylinder liner, the sleeve the piston runs inside, slides and rotates, and ports cut into it line up with ports in the block to let gas in and out. The timing of the entire engine is done by the cylinder wall moving. It's brilliant. It is also a nightmare to build, because that sleeve has to stay perfectly round, at temperature, while sliding and spinning around a piston. Hand-assembled examples ran beautifully. Then, volume production started, sleeves came off the line slightly out of round, and an out-of-round sleeve loses its running clearance where it's tightest, scuffs, and seizes. It locks the engine solid. One seizure took the only Martin Baker MB3 prototype down with it. Napier tried 18 different materials before nitriding, and lapping got them close. What actually fixed it was Bristol's sleeves. Centrifugally cast, nitrided, and held within 2/10,000ths of an inch of round. The design was never the problem. The factory was. The big one, 42 cylinders, 7 banks of 6, wrapped around a single crankcase, 6,205 horsepower, and it's a diesel. The Yakovlev M-501 is the largest piston aircraft engine ever built, and looking at it end-on is genuinely disorienting. It reads as a radial, but each of those 7 points isn't a cylinder. It's a row of 6, a water-cooled 4-stroke diesel, and development started in 1946. Naturally aspirated, 4,750 horsepower. Then they supercharged it. Who looks at a 42-cylinder diesel and thinks, needs more boost? 6,205. Now, the thing that killed it. Nothing broke. It ran. It made its power. It was canceled in 1953 because in the 7 years it took to develop, the gas turbine arrived and made the whole idea of a giant piston aero engine pointless. It was obsolete before it was finished, so they recast the block from aluminium into cast iron and sold it as a marine diesel. The Zvezda M-503, 3 per missile boat. A later redesign became the 56-cylinder M-504. It never flew. It went to sea. The Screamer, 4 blades, 6.2 meters across, contra-rotating in pairs, and the tips are going faster than sound. The Kuznetsov NK-12 is the most powerful turboprop ever put into service, and it is still in service on the Tupolev Tu-95. Each engine drives 2 enormous 4-bladed propellers turning opposite ways on the same axis. Someone wanted a propeller aircraft pushed toward 900 kilometers an hour. A propeller is a wing, and a spinning wing has tips traveling far faster than its roots. To move the aircraft that fast, the tips have to go supersonic. So they do. Every blade tip is dragging a shock wave around with it. 8 blades per engine, 4 engines on the airframe. The result is one of the loudest military aircraft ever built. And the noise isn't a flaw in the engine. The noise is the engine working exactly as designed. Those tip shocks are the same thing that buys the speed. Quiet it down, and you hand the speed back. The buzz. 1 moving part. 45 explosions a second. And it's a cruise missile. The Argus AS-014 is the engine that flew the V-1, and mechanically, it is the crudest engine here by an enormous margin. No compressor, no turbine, no pistons, no crankshaft, no valve train. It's a steel tube with a grid of spring steel shutters at the front and a fuel injector behind them. Air comes in through the shutters. Fuel sprays in, it ignites, and the pressure slams the shutters shut, so the only way out is backwards. That's your thrust. The pressure drop that follows sucks the shutters open again, and the cycle repeats about 45 times a second, right in the middle of human hearing. That's why it's the buzz bomb. You are listening to the combustion cycle itself. People say it couldn't run standing still. It could. It sat on the ramp buzzing away quite happily. What it couldn't do was make enough thrust to get itself airborne, which is why the V-1 went up an inclined ramp on a steam catapult. A pulsejet is inefficient, deafening, and structurally brutal on whatever it's bolted to. For an engine you only ever need once, all of that is fine. It was built to be thrown away. The burning tips, a helicopter with no engine in the fuselage, no drive shaft, no gearbox, no tail rotor. Instead, there is a ramjet bolted to the end of each rotor blade, glowing red hot as it runs. The Hiller Hornet, an early 1950s American prototype, burns fuel at the tips of its rotor, so the blades drive themselves round. A conventional helicopter needs a tail rotor to counter the main rotor's torque and to steer in yaw. Drive the rotor from the tips, and there's no torque going through the airframe to counter at all. At high power, those ramjets drink 600 pounds an hour. The tank holds 300. How long do you think that lasts? Just over 30 minutes, including startup and shutdown. Range is under 30 nautical miles. That's the ramjet's own physics. A ramjet has no compressor. It gets its compression from going fast. Rotor tips are subsonic, so the inlets barely raise the pressure at all, and it burns 10 times what a piston engine would. What finished it was what happened when they stopped. Dead ramjets don't just quit helping. They become drag on the fastest moving part of the aircraft. To keep the rotor turning fast enough not to stall, you had to descend at 3,000 feet a minute, twice a normal helicopter. Engine failure meant falling faster to survive. The one that dissolved its pilots. The engine is fine. It's the fuel you need to worry about. The Walter 109-509 is the rocket motor out of the Messerschmitt. Me-163 Comet And as machinery, it's almost simple. Two liquids, a chamber, a nozzle. The complication is what the two liquids are. The oxidizer is T-Stoff, hydrogen peroxide at 80% concentration. 80. Who signs off on that? The fuel is C-Stoff, 30% hydrazine hydrate, 57% methanol, the rest water, and a trace of a potassium copper cyanide catalyst. Together, they're hypergolic. Put them in contact and they ignite with no ignition system at all. That is precisely what you want inside a rocket motor and a catastrophe anywhere else. Because T-Stoff is a violent oxidizer, and at that concentration meeting, organic material sets off a decomposition that goes straight through it. Metal, fabric, and human tissue, with roughly equal enthusiasm. Ground crews fueled the aircraft in rubber suits. A split line in a heavy landing wasn't a fire risk. It was a chemical one, and the pilot was sitting in the middle of it. There's nothing wrong with the motor. They built a good engine around an unforgivable fuel. The reactor. Take a normal jet engine, delete the fire. Put a nuclear reactor where the flame used to be. That's not a metaphor. That's the General Electric HTRE, and it ran. A jet engine is a simple loop. A compressor squeezes air, you heat it, a turbine takes back just enough work to keep that compressor turning, and the rest becomes thrust. Every jet you've flown on does the heating with kerosene. HTRE asked the obvious terrible question, does it have to be kerosene? So the compressor ducted its air into the core of a live reactor. The air was the coolant, and out through the turbine. No kerosene, no combustion chamber. On paper, it never needs to land. Now the bit everyone gets wrong. The NB-36H did fly a working reactor, but that reactor never powered the aircraft. It was there to prove a reaction could run safely on something moving. The plane took off on ordinary fuel. The engine that truly ran on nuclear heat ran on a test rig in the Idaho desert. Shielding a crew that close costs so much mass, you lose the payload the reactor was meant to buy, and a direct cycle engine vents its coolant. Air straight out of a live core into the exhaust. The physics worked. The crash didn't bear thinking about. If you want the second list, the ones that didn't fit, subscribe, because there are plenty. Send it to the Scrapyard.